students, welcome to our YouTube channel Experience Tutor. Today we'll discuss class 11th physics, system of particles and rotational motion, chapter 7 ncert solution part 4. Before we start our today's session, we request you to subscribe, like and share our channel among your friends and relatives. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Let us begin today's lesson. In the last class we have completed till 7.15. Today's class will start with 7.16 or 7.16. From the uniform disk of radius r, a circular hole of radius r by 2 is cut out. The center of the hole is at r by 2 from the center of the original disk. Locate the center of gravity of the resulting flat body. Let us see the solution. So, step 1. Write the known physical quantities and draw the diagram. So, here we have drawn the diagram. So, this is the this is the circular disc, the bigger one, and smaller one is cut out. Smaller portion of disc is cut out from the bigger disc. So mass per unit area of the original disc is sigma. Radius of the original disc is r. Mass of the original disc m is equal to pi r square sigma. The disc with the cut portion is shown in the figure. So radius of the smaller disc is r by 2. So mass of the smaller disc is equal to the volume and mass per unit volume, that is pi r square. So instead of r we will write r by 2 for smaller disk, and sigma is the density. Mass per unit volume is known as density. So if we multiply that, we'll get the mass of the smaller disk. So ultimately the mass of the smaller disk is m by 4. Applying the relation between the center of masses, so it is given that OO dash is equal to r by 2. So after the smaller disk has been cut from the original, the remaining portion is considered to be a system of two masses. The two masses are m concentrated at O and minus m, which is equal to m by 4 concentrated at O dash. Here we have put everything in writing so that if you miss whatever we say, then writing is there so you can understand what we mean to say. So you will not miss anything. And we are explaining each of the term, each of the steps. So negative sign indicates that the portion has been removed. Let x be the distance through which the center of mass of the remaining portion is shifted from point O. The relation between the center of mass is x is equal to m1 r1 plus m2 r2 upon m1 plus m2. For the given system, we can write x is equal to m multiplied by 0 minus m multiplied by r by 2 upon m plus minus m dash. So putting the values and solving it, we get minus m by 4 multiplied by r by 2, m minus m by 4. Upon solving, we get mr minus mr by 8 multiplied by 4 by 3m. Upon solving, we get minus r by 6. The negative sign indicates the center of mass is shifted towards the left of point O. So this is very simple. This was very simple. Just follow the steps. You can do the sums and you can remember it as well. So let us see the next problem. Now problem number 7.17. 17. A meter stick is balanced on a knife edge at its center. When two coins, each of mass 5 gram, are put one on top of the other at the 12 centimeter mark. The stick is found to be balanced at 45 centimeter. What is the mass of the meter stick? So we have to find out the mass of the meter stick. Let us see how we will solve this. So first step, we'll draw the diagram and give the physical quantity, write the physical quantity which are given in the problem. So this is the diagram and all the values according to the problem we have indicated here. Now let W and W dash be the respective weights on the meter stick. Now mass of the meter stick is concentrated at its midpoint, that is at 50 centimeter mark. So mass of the meter stick is m, mass of each coin m is equal to 5 gram. Next step is to equate the net torque and find the mass. So when the coins are placed 12 centimeter away from the point, from the end P, the center of mass gets shifted by 5 centimeter from point R towards the end P. The center of mass is located at a distance of 45 centimeter from point P. The net torque will be conserved for the rotational equilibrium about point R. So we can write it as 10 multiplied by G 45 minus 12 minus m dash G 50 minus 45 is equal to 0 at equilibrium. So m dash is equal to 10 multiplied by 33 upon 5 is equal to 66 gram. Hence the mass of the meter stick is 66 gram. So this was also very easy. Let us move to the next question. Next question is 7.18. So in this question we have a solid sphere rolled down two different inclined planes of same height but different angle of inclination. A, will it reach the bottom with same speed in each case? B, will it take longer to roll down one plane than other? C, if so, which one and why? So there are three questions. Let us see how to solve this. So step first is write the given physical quantities and then find the total energy. So let us see. Mass of the sphere is m, height of the plane is h, velocity of the sphere at the bottom of the plane is equal to v. At the top of the plane, the total energy of the sphere is equal to potential energy, that is mgh. At the bottom of the plane, the sphere has both translational and rotational kinetic energy. So, hence the total energy at the bottom of will be half mv square, which is the kinetic energy, and plus the rotational translation energy plus rotational kinetic energy will be half I omega square. Using the law of conservation of energy, we can write half mv square plus half I omega square is equal to mgh, which is equal to the potential energy. Okay. In the next step, find the moment of inertia about its center. So for solid sphere, the moment of inertia about its center is 2 by 5 mr square. This is a formula. We can write it directly. For solid sphere is something else. For cylinder, solid cylinder, you have to remember those things. Okay, hence from equation 1, it becomes half mv square plus half, instead of Instead of I, we can write 2 by 5 mr square omega square is equal to mgh, and upon solving we get half v square plus 1 by 5 r square omega square is equal to gh. But we have a relation v is equal to r omega. So putting the value of v, we get half v square plus plus 1 by 5 v square is equal to gh. V square is equal to 7 by 10, that is gh. V is equal to under root 7 by 10 gh. Hence, the velocity of the sphere at the bottom depends only on the height and exertion due to gravity g. Both these values are constant. Therefore, the velocity at the bottom remains the same from whichever angle the plane inclined plane the sphere is rolled. So velocity remains same. Now B and C part. Step 1 is draw the figure and summarize the problem. So consider the two inclined planes with inclination theta 1, theta 2 related as theta 1 is less than theta 2. The acceleration produced in the sphere when it is rolled down through the plane inclined plane theta 1 is g sine theta 1, because it is the mg is divided into the horizontal and vertical components. So g sine theta 1 is the horizontal component in the same direction of the acceleration. So it is equal to the acceleration produced. So various forces acting are given in the sphere in the figure, and from where mainly we have to find out the horizontal and vertical components of mg. So one is the it is mg cos theta is working down, cos theta 1 is working acting downwards, and mg sin theta 1 is acting towards the motion, which is also equal to the acceleration. Now step 3, draw the second figure and solve the problem. So similar figure can be drawn for the side which is, whose inclination is theta 2. So the acceleration produced in the sphere when rolling down the inclined plane at theta 2 is g sine theta 2. The various forces acting is already given. Only the important thing is the vertical and horizontal component of mg. So the R2 is a normal reaction force for the sphere. Here theta 2 is greater than theta 1. Therefore sine theta 2 is greater than sine theta 1. Therefore A2 is greater than A1. So initial velocity is equal to u, v is equal to constant. Using the first equation of motion, we obtained as the time of roll as v is equal to u plus at. So we can write t is proportional to 1 by a. For inclination theta 1, T1 is proportional to 1 by A1. Inclination theta 2, T2 is proportional to 1 by A2. This is equation 3. From equation 2 and 3, we get T2 is less than T1. Hence, the sphere will take longer time to reach the bottom of the inclined plane, having a smaller inclination. So, this is the solution. Let us move to the next question. Now let us see question number 7.19. A hoop of radius 2 meter weighs 100 kg. So radius is given 2 meter, weight is given 100 kg. It rolls along a horizontal floor so that its center of mass has a speed of 20 centimeter per second. How much work has to be done to stop it. So let us see the solution. Step 1, write the physical quantities which are given in the problem. So radius of the hoop is given 2 meter, mass of the hoop 100 kg, it is also given, velocity is given in centimeter per second, we convert into meter per second, that is 0.2 meter per second. Step 2 is total energy of the hoop. So how will find the total energy? Total energy can be found as the summation of translational kinetic energy and translational uh, rotational kinetic energy. So E total is equal to half mv square plus half I omega square. Moment of inertia of the hoop I is equal to mr square. So putting this value in the equation, we get half E total is equal to half mv square plus half mr square omega square. But we have a relation V is equal to omega r. Therefore, putting this relation in the equation again, Et total energy is equal to half mv square plus half mr square omega square, which is equal to half mv square plus again this changes to half mv square. We have put V is equal to, instead of omega r we have put V. So instead of omega r square it is V square. So half mv square plus half mv square is equal to mv square. So work done. Now we'll find the work done, that is work required to be done for stopping the hoop is equal to the total energy of the hoop. Required work done will be mv square, that putting the value of m and v we get 4 joule. So 10 multiplied by 0.2 whole square, that is 4 joule. Let us see the next problem. Now question number 7.20. The oxygen molecule has a mass of 5.3 10 to the power 26 kg. The moment of inertia is also given, is 1.94 10 to the power minus 46 kg meter square about the axis through the center, through its center perpendicular to the line joining the two atoms. Okay. Suppose the mean speed of such a molecule in a gas is 500 meter per second and the kinetic energy of rotation is 2/3 of the kinetic energy of the translation. This relation is also given. Find the average angular velocity. So we have to find the average angular velocity of the molecule. So let us see how we can solve this. So step 1 is write the details of the physical quantity and give the given in the sum. So given in the problem. So first it is given mass of the oxygen molecule m is equal to 5.3 into 10 to the power minus 26 kg. Moment of inertia I is equal to 1.94 multiplied by 10 to the power minus 46 kg meter square. Velocity of the oxygen molecule V is equal to 500 meter per second. The separation between the two atoms of the oxygen molecule is 2r. Mass of each oxygen atom is m by 2. Step 2 is to find out the moment of inertia. Hence the moment of inertia I is calculated as m by 2 r square plus m by 2 r square, that is mr square. R is equal to under root L by m. Putting the value of L and m we get 0.60 into 10 to the power minus 10 meter. Now we'll find the kinetic energy. So it is given that kinetic energy for rotation is 2/3 of kinetic energy of translation. So putting the value of kinetic energy, formula for kinetic energy of rotation is half I omega square, and putting the value of formula for kinetic energy for translation is half mv square, and 2 by 3 the relation is already given. So m in the left hand side it is mr omega square m r square omega square, and in the right hand side upon solving we get 2 by 3 mv square. So omega will be equal to root 2 by 3 v by r. Putting the value of v and r in this equation, we get omega is equal to 6.8 multiplied by 10 to the power 12 radians second, and this is the answer. Before closing our class, today's class, we request you to subscribe, like and share our channel among your friends and relatives. Please click on the subscribe button to support us, and also click on the bell icon to get automatic notification whenever any video is uploaded by us. Thank you for watching our videos and supporting us. Thank you very much.